Can you hear me, Akshay?
Hi everyone.
Okay, all right.
Yeah, first of all, I would like to thank Netra for calling me again for this part two of this session, and I thoroughly enjoyed the first one. I hope that this one is also pretty good. And also, I would like to thank each and every one of you in this session because um, I think the main crux of this community is to communicate and collaborate with each other. So it will be great if you guys took something from these sessions. I'm definitely taking a lot from these sessions because now when I'm revising the different concepts, I am clearing some of my own doubts, and that is very helpful, and that will be very helpful when I go ahead. Okay, so having said that, uh, so last time we did emoji classifier of hands and a couple of different uh, people approached me on LinkedIn, commending my effort as well as wanted to take that to the next level. And I really appreciate that you guys are taking some effort to actually study this. And so, if you want to again reach out to me, you can do that on LinkedIn. You can find the link here on my GitHub repository, and you can connect with me over there, or you can just connect with me on GitHub. That's also an option. Okay. Yeah. So before we start, I would like
Akshay, your voice is not coming through. Can you please take a moment and then restate your last 1 minute? Thank you.
go ahead with some of the basics you guys need to. Yeah, sorry about that. There was some issue with my microphone. I believe it has now been fixed. Okay, so yeah, as I was talking about that, before we can actually start working on different models, it is very important that we should always, revise our basics just so that we have a good understanding of the basic concepts. So I will try to revise a bit of everything that you should need to know before you actually can get started with developing some sophisticated applications with machine learning. I guess all of you must have already worked on that and must be very proficient in that. But just if you want to reiterate these facts, so first is of course you want to know the basics of neural networks, how these networks work. That is must, and then of course one of the most important things that I discovered was that this hyperparameter tuning is very important. So when you're actually coding everything by your from scratch, when actually you are let's say not using TensorFlow or Keras, then you have to use mathematical calculations, and for that hyperparameters are very play a very crucial role. So, and also if you're applying for some job in machine learning, I think hyperparameters is something that people really ask questions about, and it is good to know the subtle nuances that can happen in your code just by changing your hyperparameters just a bit. Okay, and then of course you should know how to optimize your solution, and this just not applies for machine learning. in any programming, let's say algorithm or any language, you need to uh, optimize your solution so that that could be a better approach, and the computational efficiency is more. You are using less resources and doing the most work. And of course, then is regularization. As I've already told you, it is important to make your model generalized well to your training data. I mean, not just the training data, but let's say the real world data as well. So in that sense, this regularization comes into picture, because you need to make sure that your data is able to generalize well, and not just perform exceedingly well on the training set, and not and not that well on the test or the dev set. So regularization is very important. I believe you already know that there are several techniques for that. Maybe you could go with L2 regularization, dropout techniques, or even early stopping. So you can go to Google and search for different optimization and regularization techniques, and you will get a good hands-on on these uh, these subtle nuances that you need to really work on. Also, this convolutional neural networks, also known as CNNs. So I have mostly worked with them because these are mostly used for getting different shapes from the images. And I think the basic concept behind the CNN is to differentiate different shapes in the image. So if you want to work with image data, um, pixels, different pixel values, so I think you should have a good understanding of how CNN works. And if you want to know more about that, you could go and get some good research papers on CNNs, how exactly they work, and then that would be really helpful in the long run. Also, let's say RNN is also a neural network uh, that is helping solve real world problems. So as for my part, I haven't really worked on RNNs as of now. I have started to explore RNNs, and hopefully soon I'll do something on RNN, which is mostly a sequence model. Okay, and so there can be, yeah, and there are different techniques of, if you want to work with specifically image models, you could go with ConvNets or CNNs. If you want to work with sequence models, go for RNN, LSTM, GRU. These are mostly used for sequence models. In sequence models, the sequence of the, let's say, the data is very important. So when I'm talking about, let's say, voice recognition or voice translation from English to Hindi or English to another language, so in that, the sequence is very important. So for that, we use, this is actually called a sequence model. You can use LSTM, which is long short-term memory, or GRUs, which are units, gated recurrent units. So, and also attention models, in which you pay attention to specific parts of uh, the sentence, so that your model is optimized. So these are some of the techniques that you could work on, and that would really help understanding the basics, I mean, the subtle nuances that we face while building real world applications. Okay, so I think this was the basic introduction. I just wanted to reiterate all these facts so that whenever you guys are actually building your model, so you guys should need to, you guys need to make sure that you have all of these points covered. Okay, so having said that, in the last part, I believe the we finished with the Imaginator project. Only the, I guess, the application part was left, and you can go to my GitHub profile for that and get a clear understanding of how exactly that works. And also in the last part, I also mentioned about the specific research paper known as FaceNets. So this FaceNet research paper is actually developed by Google, and it is for facial recognition, building facial recognition system. And there are specific parts of why exactly I chose this research paper, because uh, this is quite easy to understand, not that difficult to understand. Second is that you don't need a lot of data to actually get good results. You can, if even if you have, let's say, 1 to 2 image of per person, and you want to uh, predict out of, let's say, 10 to 15% in your database, which exactly, I mean, the person I'm referring to. So for that, even if that person has only 1 or 2 image in the database, you will be able to recognize that very efficiently. So these are some of the points that made uh, sense to me. So if you want to go ahead with that, so yeah, so you can see the deep nets I've already uh, marked as a to do in this session. So I have done an implementation of that. This is known as facial recognition. Sorry, not deep nets, called face nets. Okay, so if you see, so this is actually taken from a research paper, in which uh, we we have a concept of triplet loss. Okay, so this is the loss function that we are going to use. And having said that, first, I just wanted to discuss with you a specific concept which is called as one-shot learning. Okay, so let's say what happens exactly in one-shot learning. So you have only one chance to actually predict whether the output is correct or not, because, well, let's say you have installed this a particular application in, let's say, an airport. So you want to commute in the airport, and your face will be your ID. You don't need to carry your boarding pass everywhere you go. So let's say you stand in front of the camera and you need to pass through the gate, and the camera present on the exit gate or the entering gate recognizes your face and lets you pass through. So you have only one shot. The camera has only one shot. He can get your photograph from where you are standing, and then map it across to the database that is kept somewhere on the cloud, and then he returns whether the person is, I mean, whether the person can enter the airport or not. So this is something known as one-shot learning, because you have only one chance to actually predict whether the person is actually uh, a valid person or not. So for that, we have a specific loss function known as triplet loss function. So we have different loss functions. Let's say for when you are actually going for, let's say, sigmoid function, where you are doing some binary classification. So in that case, we use a sigmoid loss function. So if you search for a sigmoid loss function, you will get uh, the exact, I mean, the exact picture that I'm referring to. So if you even go to, let's say, start exchange or things like that, so you will get um, different loss functions. So there are specific loss functions for specific, let's say, situations. So sigmoid is for binary classification. Then we have softmax loss for loss between n different categories. And so in this, we have actually developed our own loss function. This was already mentioned in the paper, which is known as a triplet loss function. Triplet loss function that actually train your model. So you take, let's say, the training images in forms of a triplet. So you will have one anchor image, okay, and then you will have, um, let me draw the diagram for you, and then you will be able to work on that very efficiently. Okay, so you have a one. This is your anchor image, okay, and then you have a positive image, which is of actually of this person. So these are the same, anchor and positive. And then you have a uh, negative image. So this anchor and this negative image are not same. So you want to make sure that these two values, the anchor and the positive, the similarity between these two are very high. So you want to make sure that your model recognizes similar pictures, and at the same time, the similarity between this A and the anchor image as well as the negative image should be very high. just to make sure that let's say even if the person looks similar, also then it should be able to recognize whether the person is actually the one I'm referring to. So this is the, let's say, the crux of the algorithm, because we have defined a different loss function on, I mean, on the whole for this particular problem. Okay. Yeah. So in this particular project that I have done, so I've used this triplet loss function to compare different images. Also, yeah, so some part of this is taken from deeplearning.ai. So this project is a part of deeplearning.ai, but they are actually doing it only on static images. I have let's say modified or added some functionalities to make sure that it works on with your webcam. So in the project, in the deeplearning.ai exercise, they only have different let's say static images, and I have only improved that algorithm a bit. Not exactly the algorithm, but the algorithm will remain the same from the paper itself, but only some added some functionality. And yeah, and also one functionality that I particularly added was it should recognize whether your eyes are open or not. So let's say if your eyes are closed and then you are looking at the camera, so at that time it will say that the person is not looking at the camera, so he will not let you through. So this can be something that has been used in, so I took the inspiration from the Apple iPhone X uh, model, in which they have done the same thing. Okay. And yeah, so already mentioned that detecting and we are only detecting face when the eyes are open, and if the eyes are not open, then we won't be going ahead and recognizing different faces. Okay. And so yeah, so I suggest that you guys read about this FaceNet paper. A couple of points that I wanted to mention is this. So this is actually a very difficult model. If you see, not exactly difficult, but it is easier to understand. But you actually, uh, yeah, okay. So just one question about, somebody asked me. Yeah. So he asked me, what about YOLO? Which is better? So YOLO is for you only look once, and the algorithm is for detection of different objects. So let's say if you have an image, and or let's say if you have a video and you want to detect let's say different objects from the video. Let's say you want to detect if a pedestrian is standing on the road, or if you want to detect whether the number of cars on the road, different animals on the road. For that you could use YOLO. Definitely for, I think in case of autonomous driving, YOLO is uh, for image classification, for object detection. I think YOLO is a very good algorithm. I would say, I think there are different versions of YOLO, but this particular problem is not object detection. It is face recognition. So these are two different things: face detection, face recognition. So detection is only when you want to detect whether a face is present in this particular frame of image or not. And object and face recognition is in which that you know the face is present and you want to identify, you want to classify whether the face of the image is of some particular person. So let's say I show an image of myself to the camera, and I want to make sure that the model recognizes me, that it is only Akshay that is looking at the camera, not somebody else. So this is more of a, let's say, a security measure, or uh, let's say an alternative to ID card. So instead of carrying our ID card, we can directly use this not detection, sorry, face recognition model to recognize that it is only me who is actually visiting the office and not somebody else. So in that case, these two algorithms are different. So yeah, okay, coming back to this FaceNet model, couple of things to mention is that first yeah, okay, so first it uses uh, a model known as Inception Network. So I would recommend to read about Inception Networks first, and it is I mean, it is easy to understand, and if you want, you can go to this. I think you can find, yeah, so you can go to this this blog. This is a very good blog out towards data science, and you can. So another name for Inception Network is GoogleNet, because Google developed it. So if you want to go to this website, you can, and you can see exactly what is happening behind the scenes of Inception Networks. I think there will be a pictorial representation that would be great. Yeah. So yeah. So what happens is that um, these are two different layers. Okay, and um I mean, in between that, instead of just one convolution or one max pooling, we have different convolutions. So we have a 3 by 3 convolution, we have a 5 by 5 convolution, we have a 1 by 1 convolution, and followed by pooling or convolution depending on whatever you want to go with. And then these are stacked up so that these different convolution are part of one object. So instead of going for, let's say, only one convolution, you can go for different convolutions, different uh, let's say you can add more convolutions to this particular block, and then test out your algorithm. So this is let's say if you want to try out different convolutions and check which one is better, you can directly use an Inception network in which you can stack all different convolutions, and one of them will be providing very high let's say learning rate, very high accuracy. So in that case, this is very efficient. And in face recognition, you want to make sure that, so how does face recognition actually works? You actually get different features from the image. So let's say let's say one layer would be responsible for getting the, okay, so how exactly face recognition works is that we have different features. Okay, so by different features I mean, let's say I have a jawline. Okay, and I have, let's say, nose and things like that. So these are nothing but different shapes. So convolutions are very efficient when it comes to recognizing different shapes, and inception networks are actually a form of CNN in which uh, we can try different convolutions in the same layer and get to a conclusion. But the problem with them is that this is very hard to train. And if you see the implementation that I am working on, so if you see the inception blocks that I have, so these are actually taken from the Google website. So this is a GitHub. There is a GitHub link, particular link that is also, I think I have also mentioned them. Yeah. So if you want to go there, this is also a GitHub link. Open face, Keras open face, or let's say a face in a different repository. You can visit them. So I got this network layer from them. So if you see over here, uh, we have first this block 1b. So we are doing all these different operations: convolutional, normalization, activation, padding, and things like that. And then we have, so this was 1b. Then we have 1c, okay, in which we are actually doing convolution again, and then we are concatenating different concatenating, I mean, in that we are actually connecting all these blocks. So if you see over here, in this after this convolution, what happens, this block will be connected to this block, and I mean all these 3 or 4 different convolution blocks will be connected to form a single block. Okay, then, and also you need to make sure that the dimensions match. So that is the most important thing, because when you are actually concatenating it, you are actually combining different matrix. So you need to make sure that the dimensions are correct. Okay, and so yeah, so this is actually very hard to train. Um, okay, so yeah, and also see, this is my triplet loss function. If I can, yeah, this is my triplet loss function, and so I have an anchor image, as I've already told you, which is the image that I want to recognize. This is the positive image. That is these two images are the same, anchor and positive, same person. Not the same image exactly, but the same person, maybe in different lighting conditions. And then we have a negative image, which is not of the same person. So yeah, what happened is that I have defined a basic loss function, which is the difference between the positive distance. The positive distance is actually distance between anchor and the positive value. So this distance should be very low because you need to make sure that these two anchor these two images are same. Okay, and then you subtract these two values, positive from negative, and then you add an alpha. So this alpha is also a hyperparameter. So this depends. This is actually the degree of similarity between two images. So if you are actually building a very let's say very accurate uh, model, you need to make sure that only the authorized person pass. So you can keep this alpha is very high. So this will only let's say pass the people who have I mean almost the exact same face. So even if you look away from the camera, or even if the lighting conditions fail, or there are different lighting conditions, and if the alpha is high, then the same person can be recognized as the person is actually not the same person that I'm referring to. So so you need to make sure that you can tune this alpha parameter, depends on how exactly you want to work with. So I have used a zero point 0.3 value. Okay, and then you are actually reducing the sum between the maximum of this basic loss. So and then I'm returning the loss function, and nothing, just just the input shape is this is the channel value, RGB. This is the height and width of my pixels, and then I'm compiling it. Okay, so you can let's say so actually I have not trained the model. I Because for this particular implementation you need to have 100,000 different images of different persons, and you need to make sure that there are anchor positive negative images. So you need to pass them in that order. So that took a lot of time because I'm working on a CPU, not a GPU. So that would, even with GPU, it took days. I mean, it actually takes days to more train a model like facial recognition model. So I got the different weights from open source website. So if you go to this particular, I think, implementation, or in some implementation, I believe you can actually see that they have provided weights. I think it's, yeah. So if you can see here, you can actually, yeah, the people have already provided different weights. So you can just use these weights and work with your model, because you don't want to train it again and again. And after, let's say, it takes 2 to 3 days to train. Yeah, somebody asking me, we can use Euro Darknet for facial recognition. I believe there are several algorithms for facial recognition. One is FaceNet, one is Deep Face. So I particularly worked with FaceNet because I was introduced to this on this course. So I took on this particular approach. You can try. Okay, so yeah, so after that, uh, you get, so if you see that, uh, yeah, so if you see, I think, yeah, so this particular line does that. You are loading your face from face and model. You can actually load your weight from the predefined, let's say, the weight that you get from the official website. And then what exactly I'm doing is that I'm getting the face. Yeah, I'm getting the face. Okay, and then yeah, so I'm getting the minimum distance between two faces. So this is the image from the webcam. Okay, and yeah, so this is an important line. So this is actually image to encoding. So we have a concept of encoding and decoding. So in that, let's say you have a high resolution image. Let's say 96 by 96 is also a high resolution image, and you want to get certain, let's say a number, which, so let's say suppose you pass my photo and two of my own photos, and you pass them to a specific function to get encodings out of the image. Encoding is nothing but let's say a number representation of my face. So let's say the number comes out to be 1. Okay, and then you pass another photograph of mine through the through the same system, and the encoding after that is, let's say, 1.05. So the encodings are almost the same. So this is the crux behind the facial recognition, is that the similar face or similar images will have similar encodings. So I'm converting my image to encoding, and I want to make sure that the distance is less. So I'm actually, this is some random value. So I got the encoding. Okay. Now I am getting the distance between this denk from the database and the encoding that I've already calculated using this function. And I want to make sure that it is smaller than some minimum distance. Okay. And so the minimum distance is something that you can define depending on the, I mean, you can do some trial and error with that. So this is also a hyperparameter, minimum distance. So if it is smaller than some minimum distance, that means that the two are same. So two faces are the same, and if this distance, if the encodings are pretty much apart from each other, then two different. So I believe there are several approaches you can try with this. Not just internet, you can go with uh, it as well. But I have worked specifically with particular approach. Okay. So was a brief introduction of what I could read about deep space, sorry, because I'm working on that. And yeah, also one other important aspect of that is you need to let's say study a lot of research papers. So it is very important to get a lot of research papers. So this is the repository that I refer to. I think I'll also see a that is my internet knowledge repository, RXI. So there are a lot of research papers that are coming along on this website, even in statistics, not just in computer science, in let's say different domains. You can get good research papers on that. Okay, and having said that, yeah. Also, there's this particular 2 minute. So this is this particular uh, subscriber that I am very looking forward to. This is called 2 minute papers. So this particular repository explains different research papers in under 2 minutes. So this is the approach. I would recommend that you guys see this first, and after that uh, you can actually read the research paper. So what these guys do is that they cover only the basic of what we are working with, and I mean what exactly the research paper talks about. And after that you can see and read the research paper on its own. Okay. uh, so moving on, yeah, so a couple of more projects that I am actually working on, and I think these are very interesting, and these are only related to image classification. And so this is end-to-end autonomous driving. This is actually provided by NVIDIA. So if you can see the research paper as well, this is also uploaded on the same repository that I was referring to. So this is actually a convolutional neural networks in which they have different pixels from front-facing camera, and these are directly related to the steering commands. So they will have different images of different curvature of road, and related to that we'll have a angle of the steering. So this angle will be um, I mean that depends on the curvature of the road, whether you are taking a left turn, whether you're taking right turn, or whether you are going straight. So this is actually provided by NVIDIA, and if you want, you can go through this blog by NVIDIA in which they have explained how exactly this works, and you can actually build this model. So there are particular implementations of that. I believe a lot of people have already worked on that, and I have the data set, I believe. Let me show you the data set of how exactly this works. Uh, okay, so this is I just started with this project couple of weeks back, and I'm still working on this. As you can see, there are different images. I believe the size of the data set is around 3.5 GB. So you can see there are different images of roads, and uh, so different images of road. So in this particular image, you want to make sure that you turn right, and at the end, I believe there's that file that is related to each image, and it shows the steering angle. So in certain images, the angle changes, which means that you need to maneuver according to the road ahead. So I believe some people have already worked on that and provided a very good implementation of that. I think this is this is very easy to do. The only difference, the only problem that I faced was that the size of the data set is very huge. So you need to make sure that you have a good understanding. Yeah, so only thing that you need to make sure is that you have uh, good understanding of how to work with a very huge data set. So yeah, I think this somebody has already done that. I looked at a video only, and that was that looked very enticing. And couple of weeks after that, I started working on the same problem myself. So yeah, so as you can see, this is actually the video, and you can see the different steering angle. Uh, so this is just let's say a rough model. The steering wheel is actually not working that well, but I believe with with a good model, you can actually work on something like this. So this looks very good, and this can actually be one of the key features when it comes to autonomous driving. So autonomous driving is just not controlling the steering wheel. It is actually object detection. You need to detect whether the pedestrian is on the road or not. You want to stop your vehicle in time or not. Or let's say you want to make sure that you follow the traffic signals. So for that, you need to make sure that you detect the traffic signal correctly, as well as the color on the traffic signal. And yeah, so these are some aspects that you need to make sure and work with. But as a starting point, I think this data set is you could actually work on and refer to. So yeah, so I think that you guys could work on this problem as well. Okay, so having said that, there's also something known as deepfake, in which we let's say superimpose an image on some other person. So there's actually a very good video by Siraj Rawal on that. And so this is actually end-to-end autonomous driving is actually provided by NVIDIA itself. You can go to the official website or some dev blogs, and you can find some good, let's say, going ahead points. But deepfakes is actually done by somebody from Reddit. So we actually don't know the identity of who did it, but you can actually get very good results by superimposing different faces on top of a different person. So it is actually like applying filters, but it is much more convincing. So you can also work on that. So if you want to work on deepfakes, I think there's a specific, yeah. So if you want to work on deepfakes, I think Siraj Rawal already put a GitHub repository link as well as a video on how exactly deepfakes work, and you can also work on that particular set of problems. Okay, so if you can see, you can face swap different person, superimpose images, as well as let's say, uh, and also the most important thing is that you can actually differentiate between a real video or a fake video, or some video that has already been tampered with. So this is actually a good practice, because a lot of videos or a lot of photos have been morphed. So this model actually differentiates between the two. Okay. Yeah. So this, you can go through Siraj Rawal's GitHub repo and get some information about deepfakes. Okay. And then other applications that I interested. So these, so particularly I'm working on this end-to-end autonomous driving implementation as of now. But I've just started the implementation, so it will take some time, about 1 or 2 months, before I can actually get a good working model. Uh, Also, yeah. So also some of the other parts that you could work on is, uh, let's say, I think medical image diagnosis is something that a lot of people are actually working on. So yeah, so you can use different deep learning applications in medical imaging and things like that. So I think Siraj will also put up a video regarding retina scan or eye scan, and I also came across a product that used to track different teeth. I mean, the condition of the teeth, and it used to recognize whether you have some condition in your mouth or in your gums or not. The market is towards this medical imaging is kind of growing right now. So if you are actually working in image classification, or you want to work specifically with image data, I think this is something that is very intriguing. Okay. Uh, so any question that you have, according to you, because the specific time that I gave you for like 1 week was to come up with some of your own ideas, or let's say some of your own problems that you are facing, or some of your own concerns that you have. So you can put that across to me, and if I get the solution, or if I have already faced that issue, I will give you a better approach of how exactly you can go ahead with that. So that would be a good time to actually reach out to me and uh, connect with me. And also, if I'm always looking to collaborate with different people, so just so that you want to work on, you have a good uh, problem statement, and you want to actually work on that with me, you can always reach out to me on LinkedIn or GitHub, anywhere you want to, and we could actually work together and build a specific project. Okay. uh, okay, yeah. So also this research paper that I was talking about on end-to-end learning for self-driving cars. So this was all actually downloaded from the repository that I was referring to, rxiv.org, and this is mostly mainly done by people at NVIDIA, and mostly working with CNN. So if you see, even in the first line, they have mentioned that they have used CNNs to map raw pixels, from a single. uh, So usually in industry-oriented applications of classification, let's say if you want to actually develop a self-driving car, so there are different camera from different angles, and there are also different sensors. But however, we just want to make sure that training such a model becomes very complicated. So if the image is only from a single source, then that becomes a bit easy to classify as well as easier to train. Okay, so mostly they cover all the basic details of how exactly they have worked on. So what exactly they are doing is they have a CNN back propagation to adjust weights, and according to the weights, the sharing angle is generated. Things like that. Okay. So also they have also mentioned the functions. I mean the convolution filter that they have used. You can use the same features and build a your own model, or you can use a different set of features to get a implementation out of that. Maybe you can develop a more accurate solution to their problem. Okay, and yeah, so I think looking up
Actually, I
specific.
have a question, couple of questions.
Okay.
So what, I mean, it looks like, we can capture the video, as we drive, the road conditions, and possibly take the turns also as the, how we use the um, the turning wheel, right? The control.
Yeah.
Both these things captured as we drive. Let's say as we drive, we can capture it through a video, front end camera. Just as an first example, front end camera, only one camera, and also the tones that
Yeah.
gets recorded in a, let's say, in a recording system. That
Okay.
could be used as a way of learning and then actually verifying whether as a training data set. I'm saying, so it becomes a training data set. So we have the road conditions where actually the turns of the wheel have been recorded also. So both these can be used. The turning of the wheel in a certain direction, certain angle, and the image of the camera that we captured, image of the video that we captured, can be used as a simulated data to build the model, right? For one camera,
Yeah.
right?
Yeah, that is exactly what is happening from. So that is the, I mean, how exactly we are getting the training set is that we have a camera records the, let's say, the road, and the turning of the wheel is actually the angle in which the steering wheel is rotating.
Hmm.
So you can use that as your label, Y label,
Hmm.
and the image that you're getting from the front facing camera is actually your X, the number of features that you have.
Hmm.
So you want to make sure that you recognize the road out of that image, and you need to make sure that the what is the curvature of the road that you are seeing. So I think a CNN is very I mean a sophisticated CNN is very good in that. You want to make sure that you are actually capturing the road and not anything else.
Hmm.
So I think you can work on that. So things will become more clear once you actually read the research paper that is provided by NVIDIA. And if you
So,
want, you can
what
actually
I'm
see implementation. For some people, in
so
that
what
case, you can actually see.
hmm. So what I'm saying is, how do we build the network? In order to build the network, we need the training data. So I was just saying that we can actually capture the training data using our own camera and our own. Somewhere we have to capture the turning angle of the wheels also, right? So we can create our own training data. That's my question, right? Of course, this is going to only give you knowledge about the existing roads that the car has traveled, technically speaking. But on the new road, how
Yeah.
it will behave, it's there is more training that is needed, for that one.
So the training data that they are providing is actually from the US, and the roads in India are actually very different when it comes to the difference between roads in US and India. So if you actually want to build a model for Indian roads that work with the Indian roads and Indian how the roads are built. So in that case, what I would recommend is what you are saying, Netra, is that you can actually make your own data set, and the steering angle is maybe, I think, I'm not aware of how exactly can you calculate that angle, but there will be certain sensors, I
Yeah.
believe, that actually can give you the steering angle, or let's say not even the steering angle, you can even calculate the angle at which the wheels are turning. So there is a particular angle in which your wheels are rotating just to make a left turn. So and that would be directly proportional to the rotation of your steering wheel. So even if you get that, you can directly use that to map it to the steering wheel and make your own data set.
And then we build the CNN and verify that our learning is fulfilling exactly those turning angles and directions. Okay, sounds good.
Yeah.
Okay, thank you.
Yeah. So I think one of the most important points that Netra mentioned is that when you are actually building a business case, you want to solve a business case. In that sense, you want to create your own data set because you need to make sure that your data is actually relevant, it is validated, and it is not, let's say, somebody is not tampering with it. So when I get data from let's say a different source, so that source may be relevant or it may not be relevant, and even if it is relevant, or let's say whether it is validated or not. So one of the most important things that I realized is that if you have the opportunity to make your own data set, maybe it will take a lot more time, let's say 2-3 months more, but that is the most optimized approach, because in the long term, when you are actually deploying it in real world, then in that case you are actually testing it in the real world. So if you are actually creating your own data set, then you can get different uh, data from different sources because you know what you are modeling. So in that sense, I think creating your own data set is one of the most important, I think the most important thing when it comes to machine learning problems, because other things could be done by anybody else, because convolution CNNs are not very difficult to achieve or not very difficult to understand. But that if you are getting a very good data set, then that would be really helpful when you are actually building a business case.
So would you like to work with the India data set, or do you think it is easier to work with the US data set?
uh, I think US data set is much easier to work on because the roads are very wide, and you can actually get a good view of the roads. But having said that, Indian roads are more challenging. So if you are actually wanting to challenge yourself or build a good model that is sophisticated enough to learn on different roads, then you could go for something like creating your own data set in from Indian roads. Um, but yeah, I think for starting out, you can actually work with this particular data set that they have provided, that is from, I believe, from the US only. And
Oh, okay. So there is already existing US data. That's what you would recommend,
yeah,
as a learning process. Okay.
learning process, you can go ahead with that.
Sounds good. You also made some interesting things, interesting comparisons about, to determine gum disease problems, looking at the fake face application. I thought that's what it is, that was interesting. You mentioned about few other things, right? Identifying a same individual, following that individual in an airport or in a crowd, using the triple loss function, um, and You called it, I don't remember the word for that. So those are all good. And then you have the emoji, you have the besides emoji, the droopy face or droopy eyes. You have the droopy
Yeah.
eyes, hand movement, digital recognizer, facial recognition, FaceNet, Devanagari recognition, drowsiness detection, and on top of it now the driving cars and so on. So if somebody wants to learn all these things, let's say, how long it will take, you think? Weekly they put in 10 hours.
Yeah, I think it also depends on the individual, because I was never very good at studies. And in this machine learning, you need to make sure that you have good understanding of mathematics. So for that, I would recommend everybody to please talk to Netra about mathematics, because he only made me realize that the importance of mathematics behind machine learning. Because before that, I was not that much into mathematics behind machine learning, because I thought that that is something that won't be relevant to engineers like me. But I think after talking to Netra, he spread some light on different techniques of not exactly just gradient descent. There are uh, different techniques in which you can find the I mean the minima of a function. So I believe it takes a lot of time. It will be a bit difficult, because I have been in machine learning for about a year now, and I am still struggling to get the basics. So it takes, yeah, I'll say that per day, even if you study for like 1 hour and revise what you have studied earlier, because that is the most important thing, is that you revise what you have studied earlier. So even if you study like 1 hour a day, and but you study continuously even on the weekends, so then that would be very helpful. So that around 10 hours per week would be, I think, more than enough.
So for 10 hours per week, and these examples can be worked out in 10 weeks.
Yeah, so I mean, you can actually progress slowly, because initially when I worked with, I started, I think, with a logistic regression of some problem. So there was a binary classification problem, and I worked on it for about 1 to 2 months, and after that, it was a very simple problem. But even after 2 months, I was struggling at it. But after, like, say, 2.5, 3 months, I got the problem, exactly the solution. But after that, that was a part of my learning process. So whenever I so from that, I started building more complicated models, and reading a lot of research papers, or let's say reading a lot of blogs, talking to a lot of people, attending different webinars. So from that, from each source, some certain values, and you can put it into the next project.
So when we say AI, I want to know your perspective. I take this moment to almost like interview you. Sorry, it
Okay.
was. I think it is a good idea to hear out from people like you, especially for learners, who are attending this also. So from your perspective, these examples along with RNN and the self-driving car. Let's say call this as a course. Will this be called a complete AI course?
Uh, Definitely not, because I think AI is so vast that machine learning is just a part of AI, and there are different aspects of AI when it comes to, when you're actually talking about actual AI. I think I have only covered like 3 to 4% of what uh, machine learning is all about, and this field is so evolving that let's say per day there may be tens of hundreds of research papers that are being published, and some good research papers are being tossed off the shelf. So I think it's such a vast field that you cannot cover everything. But at the same time, if you are actually good at just one thing, that would be, very helpful.
Okay, so as I think about more questions for Akshay, I really want every one of you to join a conversation with him. If this is a good time, Akshay, it's your call. Is it a good time to everybody to jump in, talk to you, ask questions, whatever they have? Or
Yes.
if you want to finish something before that moment, that's fine.
Yeah, I think just one thing before you can actually.
I couldn't hear you, Akshay. Mohammed, Your mic is on. Sriram, your mic is on, but if you want to ask question, that's okay. Otherwise, please mute it out. I did unmuted everybody so that everybody can ask question. Anybody can ask question. Akshay, you can repeat whatever you said because I didn't hear last 1 minute.
Yeah, so just one last thing. Netra mentioned about what exactly is AI about. And for me, starting, I think I was about building cool stuff, doing very cool things. With let's say different technologies, autonomous driving is a cool aspect of machine learning, and that's what I thought when I started out. But recently, I came across this video that was very insane to me, and I just wanted to share that with you because I think this is actually a story that you want to go on. So I'm just playing a video. Go inside.
Sorry, I'm going to mute out. Okay, yeah, repeat that because it was mixed up voice.
Yeah. Okay. So yeah, as Netra mentioned that uh, machine learning is. I mean, he asked me what AI is about. I mean, what is according to you is AI. So in the starting, I thought that maybe I'll develop some cool applications in machine learning, and autonomous driving is something that I was very intrigued with. But recently, I came across this post, and this is actually what machine learning is about. This is actually what every technology is about. It is about helping other people. So this particular video I came across in Google I/O, and this is one of the key parts of machine learning that I believe would take this to a long journey. So this is the video that this is actually Tanya's story, and I would play the video, and we can talk about this after the video ends.
Hi, I am Tanya. So putting dots and dashes with switches mounted near my head. As a very young child, I used a communication word board. I used a hair stick to point the words. It was very attractive to say the least. Once Morse code was incorporated into my life, it was skydiving so much, same kind of feeling. Through skydiving, I met Ken, the love of my life, and partner in crime.
It's always been very, very difficult just to find Morse code devices, to try Morse code.
This is why I had to create my own. With the help from Ken, I have a voice and more independence in my daily life. But most people don't have Ken. It's our hope that we can collaborate with the Gboard team to help people who want to tap into the freedom of using Morse code.
Gboard is the Google keyboard. What we have discovered working on Gboard is that pockets, it's like tens of millions of people who have never had access to a keyboard that works in their own language. With Tanya, we've built a Gboard for Morse code. So it's an input type in Inception. You don't need to get somebody that's a normal board just would be able to.
Excited to continue on this journey. Many people will benefit from this, and that will meet no end.
Yeah, so this was the story of Tanya and how exactly machine learning changed her life, and she helped integrate Morse code into the Google Gboard so that people with disabilities or with special abilities can use the Google keyboard and communicate with the world. So I think this is what machine learning is all about. It is helping the people who are in need. Yeah, Netra. So I think
So in this case, in the two session, you kind of gave one example, detailed example, and also review of all kinds of different applications one can build. And the central part of this seems to be image recognition. So, and of course, it included the self-driving cars also, because there the camera is capturing the images, and the images are used to resolve the direction of the car has to go at every moment in time. So so overall, I think we promised the people that we will provide creative applications of image recognition, and which you have done. And now I understand why you will say that you are saying that this is probably 5-10% of the AI. So nonetheless, I think it has been a very interesting as well as very encouraging that after all, creating self-driving cars are not that complicated. For example, I hope the attendants feel that way. The people who are attending now today, there are still 14 people there, including me. Feel that these are all possibilities that we can build. You guys can build. I'm talking about people like I'm just going to just read the names like Aragiri, Divya, Gwen, IOA meeting group, Kumar, Mehan, Omni, Parvinder, Ravinder, Sriram, Uday Ganesh. So that's great. I certainly appreciate Akshay coming in and talking to people who are generally connected to Institute of Analytics group of people community. I will invite you for a possible we still have summer, so if you will be, this is an open invitation, before everybody is there in the meeting, will you be, will you be able to find time to provide a summer course, for people who are interested, possibly, students coming from US as well as in India, let's say maybe 2 days or 3 days course continuously, or some such program which will use 15 to 20 hours, where at the end of the course, people will be going out saying that, no, they can do these things, okay, repeat these things. Think about it. No pressure to commit now, or no pressure to say anything right now. Just think about it. I certainly will be very interested in exploring that. These are all fascinating applications of machine learning, and I think people will have a chance to learn and apply them before the end of summer and claim some talents for their jobs too. How does that sound? And with that, we will close it with with the possibilities of questions again open for the attendance.
Yeah, I think the let's work on that, because I think I know most of machine learning. I know just a bit, so I will try to the summer course that you are referring to. I would definitely be thrilled to be a part of that, and I have time. I hope that I will actually model the course, and I will just let's say give you the details of what exactly will I be talking about, and things like that. So yeah, I think mostly it's a yes, and so people who want to join me in that course are most welcome to. And a big shout out to everybody who has actually joined this meeting, especially to Gwen, because she has always been supportive of me, and Netra, you as well, because you are giving me such opportunities to connect with such great people.
Everyone, you are open. Please open up your mic, say something, whatever you want to say, or if you have any questions, go ahead. It's your time. I have been hogging the time, but it's your time now. So I'll be quiet. Go ahead, please. If you don't have any question, please type, saying that I'm good, thanks, no questions, or I'm good.
Hi, Akshay. This is Sriram.
Hi, Sriram.
Yeah, I want to know what is the scope for this image processor like in AI?
Can you please repeat that?
I'm sorry, can you type the questions? I'm not able to hear Sriram, if you don't
Are you
mind.
able to hear now?
Yeah.
Hello?
Yeah, go ahead, Shiva.
Yeah, I want to know what is the scope for image processing in AI.
Okay. So yeah. So basically, the but about learning about vast subject. And you're talking about, let's say, in terms of the capability of image recognition or image processing. Uh, then, let's say, autonomous driving, you are actually using photographs.
Okay, Akshay, can you hear me? I'm going to repeat what Sriram has said because I couldn't hear before. I couldn't hear before, so I'm going to repeat what he has typed. Okay, Akshay.
Yeah.
So what Sriram is asking is, in AI, what is the
Yeah.
scope of image processing?
Okay. Yeah. Okay. I think the scope of image processing is particularly. I mean, image processing is somehow used extensively in AI because I think, let's say, even if you pick this application of autonomous driving, so one of the key concepts is you want to recognize the road or you want to recognize your surroundings using the camera. Of course, there are different sensors as well for recognizing different values from your car, but camera plays a very important role in that. So image processing is definitely, let's say, image processing is one of the core areas that you could work with, and if you have good understanding of image processing, then that would be a really plus point. And I know people that are doing specialization in image processing, and they are working specifically in the AI and ML domain. So the scope of image processing is related to machine learning is very good, and even if it is not related to machine learning, then also image processing in itself is a very interesting subject.
Okay, I will add to that some comments because I'm also trying to understand and articulate, for the students. So first of all, AI is, is something, it has to interact with humans. Okay, that's what AI means. Otherwise, it is just an algorithm. So artificial intelligence is commonly attached to AI, commonly attached to activities where the machines interact with the humans. Okay, broadly speaking, that's a property. The second property is that human eye, and for the same reason, images are 80% of the knowledge gained by the around the environment. Okay, so the AI without image processing is very much limited, and AI with image processing is extremely important and very powerful. So in that sense, image processing is core, in my opinion, is one of the core. Sound is another one. So the five senses, exactly like five senses, those five senses contribute to the 100% of the experience of the real world around the machine. So image processing is one of the core relevant component analysis. So Sriram asked also the question, I will leave it to you to answer that, Akshay. Is Python mandatory?
Okay. So definitely not. Python is not mandatory, I believe. But having said that, I think most of these programming frameworks that I am working with are available in Python. So I think um, Python is a useful tool because in the end you want to make sure that you are actually able to demonstrate your project. So you can also work on MATLAB. I have worked on MATLAB in some of my previous implementations. I have used MATLAB. But I think, yeah, Python is easier to understand because it is not as complicated as Java. Uh, so I think, yeah, it would be a good point if you have Python. So I would recommend that, yes, probably because all the implementations that I am seeing are in Python only. So yeah, having Python will be a plus point. So you can go ahead with that. Also, I got one other question by somebody who has posted in chat. He wanted to implement, he implemented the Emojinator, the project that we discussed in the last part one session. And now he wants to add face emojis. Yeah, so for that, I believe you have to do a bit of research on how exactly that could be implemented, because I have some idea of how exactly I want to implement that. So you want to make sure that you capture the face on the whole, and the most important part will be you capture different features from the face. Let's say the eyes, because if you change your eye, let's say the configuration of your eye, and according to a specific emoji, you want to make sure that the emoji also captures that. So you need to make sure that you have different features classified. So if you want to pout, let's say the pout emoji that we have, so you need to make sure that your image is, I mean your model is actually classifying your lips as well. So lips is also an important feature. So things like that, you need to make sure that you classify or you capture different features on the face, and according to that you can develop your model which has this capability of face emojis.
There is a question for you from Omni in my place, in my chat. Actually, I'm not sure whether you're seeing that. His question is, what computing resources do you use for your projects? Is there a cloud-based solution for, for that cloud-based solution? And then the sentence doesn't come out gel well, but who do not want to invest in hardware. Okay. Is there a cloud-based solution one can use instead of buying hardware?
Yeah, so definitely I think cloud is actually a cheaper version, as well as a lot of people are actually migrating towards cloud. So I think you could use that. So I am personally using a very low end laptop which has 8 GB of RAM, i3, and only say I using the CPU. So you can use Floyd Hub. So if you, I already mentioned in this of this in the uh, previous section as well. So you could go to this repository floydhub.com, and this is actually a deep learning platform, and it is free. I for like few projects, one project per something. So it is mostly free, I believe. So you can use that, and it is very easy to understand. You can see the tutorial, and you can work on that. So yeah, even if you don't want to invest in the hardware, you can definitely go with this one. Yeah, and I think another question is somebody is asking me about dlib. So yeah, so dlib is specifically used for this dat file that actually gets the face, detects the face from the image. So for that you are getting the error. I would recommend you to follow some blog. So there's a specific blog by PyImageSearch, Adrian from PyImageSearch. He has given a good blog on how you can install this particular dependency, dlib. So you can go ahead and go with that.
So also, I imagine these things will become easier in GPU. I mean, faster in GPU.
Yeah,
Okay.
yeah. I think because in GPU you have the parallel processing power, so it becomes quite easy if you want to train a model in GPU. And so for that, but I think the GPU, the I think 1080, NVIDIA 1080 is the minimum one that supports CUDA. So you can go to the NVIDIA website and check all these GPUs that are supporting deep learning, let's say parallel processing. So, and get one of those, or you can even use cloud for that. Cloud Hub is easy, the setup is easy, and you can work with that as well. And somebody is asking me to give the contact number. So you can definitely reach out to me on LinkedIn. I've already told you that you can reach out to me on LinkedIn over here, and I will definitely share my contact number with you. I can share my email with you. No issues with that. I've already shared my email in the last session as well. Let me share my email, and after that we could, if you want, you want to talk to me personally, we can also do that. So I've already shared my email, my Gmail account. You can mail me if you have some idea or if you have some suggestions for me.
Excellent. Sounds good, Akshay. I appreciate your time and I appreciate your effort to join this group of people who have been, probably some of them have been waiting to hear from you quite some time. This provided a platform for them too, in addition to Institute of Analytics group of people or its community. So thank you very much again, and I'll speak with you. I'll explore further other things that we can do together. One of them I already mentioned in this talk a little earlier, in this discussion a little earlier. So thank you very much, everyone joining from wherever you are from. Some join from US and some join from India. It's great to see you again. Keep in touch. There is more coming out from my table to you as messaging, in terms of what we can do, learning together. Okay. Thank you very much, everyone. Thanks a lot, Akshay. Keep in touch.
Thank you.
Bye-bye.
Yeah,
Bye, everyone.
Bye bye. Thanks, Akshay.